So the next thing that we're going to look at is the law of cosines. Okay, so we've talked about the law of sines, and the thing with law of sines is that you use law of sines anytime you have an opposite pair. Okay, so if we look at this example right here that we're going to do in a minute, you're going to notice that we don't have an opposite pair, right? I know angle A, but I don't know the side opposite of it. I know this side over here, but I don't know the angle opposite it. I know this side, but I don't know its opposite angle, right? So I don't have any spots where I have both parts of this set. So a complete opposite pair. That is your cue that you're going to use law of cosines. Anytime you do have that opposite pair, definitely use law of sines. I think it's a lot easier for the most part. But if that's not the case, then you're going to have to use a law of cosines. Okay, so let's talk about what the law of cosines actually is. And I'm going to set up my triangle here, just kind of like how we have been doing. So opposite sides match letters. Okay, now we're not going to go through the proof of this one. We could, but I just feel like going through the proof of this one is not quite worth the time that we'd invest into it. So this is going to be one where I'm just going to kind of give you the rule. Okay, so here's how this works. It starts out like the Pythagorean theorem, but then there's a little bit extra to it, right? We can't use the Pythagorean theorem in a non-right triangle because Pythagorean theorem is specific to right triangles. Okay, but it kind of starts out that way. So it starts out with side c squared equals side a squared plus side b squared, right? But then additionally, it's going to be minus 2 times side a times side b times the cosine of angle c. Okay, so all of these are all side lengths, and then you got this one angle at the end. And the key thing that you have to have here is that these two have to be an opposite pair. So if this is side C, then this has to be the angle opposite of it. Okay, so it starts out like the Pythagorean theorem, right? But with this extra stuff. And again, these two have to be an opposite pair. That's really important. Okay, now you don't have to just use side C here. Similarly, you can say that the law of cosines is that side B squared equals side A squared plus side C squared minus 2 times A times C times the cosine of angle B. Okay, where again, these are all sides. Okay, and you're going to notice that these letters are the same, right? So all these guys are on the same side together. And then this has to be an opposite pair. So if this is side B, then this has to be angle B, the angle opposite of it. Okay, and then similarly, we could also write this that if I wanted to find side A squared, I would do B squared plus C squared minus 2BC times the cosine of angle A. Okay, so we wrote this out 3 times, not because the letters particularly matter, but because I really want you to see the structure of what's going on in this law of cosines, right? Where you're starting out in a regular Pythagorean theorem, you can't arrange it this way. It's got to be arranged with c squared by itself. Okay, but with a law of cosines, you can. So a squared equals b squared plus c squared minus 2bc, right? And notice that those are all the same letters. And then times the cosine of a, where these guys are opposite of each other. Okay, so that's the kind of idea of how you're going to set up law of cosines. So let's look at this example down here. So we're going to solve this triangle. And as a reminder, when it says solve the triangle, what that means is find all the missing parts. So in this case, we're going to have to find side BC and then angle B and angle C. All right, now we're going to have to start by finding this side because I don't have enough information to find anything else. Okay, if I tried to use the law of sines, we already discussed you can't use the law of sines here because I don't have an opposite pair. And if I wanted to find one of my two angles, to find the angle, I'm going to need to know the opposite side to be able to use law of cosines, and I don't have that here. So I'm going to have to start by finding this side. Okay, so we're going to start by finding side BC. Okay, and actually using the law of cosines to find a side is really easy. Okay, so we're just going to kind of plug this information in. I want to find x, and I know the angle. So these guys are going to have to be my outside edges. Okay, so it's going to be x squared equals the sum of the other two sides squared, so 28 squared plus 27 squared, minus 2 times those same sides, 28 and 27, and then times the cosine of the angle opposite x. So the angle opposite x is 116. So cosine of 116. Okay, great. So now when I look at this, all of this stuff on the right-hand side, this right here, there's no variables there, right? That's all numbers. So I'm going to take all this stuff and I'm just going to shove it into my calculator. Okay, so I'm grabbing my calculator and I'm just putting this in. You don't have to worry about setting up any order of operations or anything like that. That's going to already be taken care of. Oops, I typed something wrong. What did I type wrong? Oh, I have a minus and then a times. So oops. Oh, because I missed the 2. So I need to add in a 2. There we go. All right, now it's typed in correctly. There we go. All right. So this works out to x squared equals 2175.8-ish. And then we need to square root that. So I'm going to do square root, and I'm going to tell it second answer because you want to make sure that your answers are as closely not rounded as possible. You don't want to round your answers unless you absolutely have to. So I just took the square root of the previous answer. Okay, and there we go. That's what my side length is. Okay, so that's really easy. Finding side lengths is not a big deal using the law of cosines. All right, so next we're going to have to find an angle. Now, if I were doing this problem for a homework assignment, this would be the point where I would switch to the law of sines. Okay, because now I've got an angle and I know its opposite side. We just figured that out. So now I have enough information to do the law of cosine, or I'm sorry, the law of sines. So I would switch and do that and do my ratios. Sine of this over that equals sine of the angle over that, right? And I'd calculate it that way. Okay. But because I want to go over how to use the law of cosines today, we're not going to do that. Okay, so I want to show you how to use the law of cosines. So we're going to go through and use the law of cosines to find an angle because you will have to do that sometimes. But again, if this is the problem that I was actually doing, I would just switch to law of sines from here. Okay, so let's find angle B. So we're going to find angle B next. Okay, so angle B, if I want to find that, there's only one angle in my equation, right? So I know angle B is going to have to be the angled out here, which means I need to start with the side opposite B. So the side opposite B is 27. So I'm starting this equation 27 squared. Okay, and then that's going to equal the other two sides squared. So 28 squared plus this 46.6 squared that we found. And then it's minus 2 times those same sides, so 28 and 46.6, and then the cosine of the angle that we're looking for. All right, now this one is going to be a little bit pickier about what you can do on your calculator because of this variable. Okay, so here's what I'm going to do. I'm going to put 3 different things in my calculator. Thing number 1, 27 squared. Thing number 2, I'm going to combine just those 2 things together. And then thing number 3 is I'm going to combine those together. Okay, so I'm kind of doing 3 steps all at the same time, and those are all going to go into my calculator. Okay, so on the left side, 27 squared, according to my calculator, is 729. Okay, I'm going to do 28 squared plus this 46.6 squared. Right, so I'm just entering that part together. So that's 2955.56 minus, and then I'm going to do 2 times 28 times 46.6, which is 2609.6 times the cosine of B. Okay, great. Now, this next step, this is the most common mistake that I see when people are doing law of cosines problems. You cannot subtract those 2 numbers, okay? That will not work. You will not get the right answer if you do that. Okay, order of operations says that when you're simplifying something, you have to multiply before you can subtract, right? Well, this is a product here. So I can't subtract these 2 numbers until after I've multiplied. Okay, as a similar thing, it's like if I had an equation like this. This is really the same equation as that one, just with different numbers, right? It's a number equals a number minus 2 times a variable, right? If you were going to solve this, you know how to solve this. You'd subtract the 5 from both sides first, right? And then you divide by the negative 2, right? Those are the same steps that we're going to use on this problem. I'm going to subtract this from both sides first. And then after we do that, we'll divide by that number. Okay, so again, that's the most common mistake that I see when people are doing this. So I'm subtracting this 2955.56 from both sides. Okay, so 729 minus that 2955 is negative 2226.56. Don't drop your negative sign. Oops, I missed part of my number. There we go. So we don't drop that negative sign. And now to get that cosine of b by itself, I'm going to divide both sides by this negative 2069 number, 2609. I think I just wrote that wrong. Okay. Ooh, I'm sorry. I keep hitting the wrong thing here. Okay, that doesn't cancel out. That I have to actually divide. So I'm dividing that number by negative 2609.6, which is about 0.853. So that's the cosine of my angle. That's my ratio. So I need to figure out what the actual angle is. So I'm going to do the arc cosine. And again, you don't want to round. So I want to do arc cosine, and then I'm doing second and the negative button to get my answer. So it's going to take my previous answer, and that is about 31.4 degrees. Okay, so there's angle B. All right, so like I said, law of cosines when you're finding a side, not a big deal. Finding an angle, a little bit more annoying. It's not awful, but it's a little bit more annoying. So if I were actually doing this problem on a homework assignment, after I found this side, I would switch to a law of sines because I'd have an opposite pair then, okay? But sometimes you're gonna have problems where you can't do that and you're gonna have to find your angle, okay? So that is kind of your way that you do that. All right, we got one more thing that we need to find, right? We need to find angle C, but luckily we are now in the camp of good things, right? All triangles add up to 180 degrees, so I can subtract that, not 46, the 31.4, the angle that we found over here, and the 116, and when I calculate that, that works out to about 32.6 degrees. So there's angle C. Excellent. All right, one more thing to make note of. You can only use the law of sines to find acute angles. It does not work on obtuse angles. Okay, so when we have this example, say instead this example, when we looked at it, right, instead of giving us the angle or the information they did, that they told us that this was 28 and this was 27 and this was 44, right? And they asked us to find an angle. In order to do that, you would have to start by finding angle B with the law of cosines, and then from there figure out what angle C is, either with the law of sines or another law of cosines, either way. Okay, and then this guy would have to be the one that you would do 180 minus B minus C. Okay, because you can't use the law of cosines to find obtuse angles. All right, and it kind of falls back to what we talked about with the law of sines, right? There are some angles that have the same cosine. The cosine of a 30-degree angle and the cosine of a 330-degree angle are the same. So if I do the arc cosine of that number, it's always going to tell me the acute angle, not the obtuse one, right? And that's what's going to throw you off. Okay, so you're going to have to make sure that you always are doing this where you're use the law of cosines or sines to find the acute angles first, and then do 180 minus to find the obtuse angle. Okay, so just make sure that you make note of that. That is a thing.